Students, there is a correction over here. It's the impulse imparted on M1. This delta P1 is the impulse imparted on M1. And this is the impulse imparted on M2. Okay? Please correct it. Delta P1 is the impulse imparted on M1, or you can say impulse on M1 due to M2. Okay? And this is the impulse imparted on M2 by M1 or due to M1. Have you corrected?
Yes, sir.
Yes, sir.
Noted?
Yes, sir.
Shall we proceed further?
Yes, sir.
All of you have sent it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now let us we have done the type of collisions. So basically we deal with the extreme types. Extreme types. What are these extremes? Two extreme types. One is elastic collision. So one is the elastic collision and another one is completely inelastic. So extreme types of collisions that we deal with, basically elastic collision and completely inelastic collision. So elastic collisions and completely inelastic collisions. So elastic collisions, they have the initial momentum is equal to final momentum. So whenever collision word is there, so initial momentum is equals to final momentum. Here in elastic collisions, kinetic energy is also conserved. Okay. But here we have a loss of kinetic energy. So initially it was greater and final kinetic energy of the system is lesser, and that may be equals to the heat produced, equals to the heat energy produced, that loss. So energy transformed from one form to another. So these are the concepts. Okay. So in the last lesson we did couple of questions based on elastic collision, and now we'll do a question related with completely inelastic collision. Okay, that's a very, very important question, one of the most important questions of this chapter even, and that is exercise question 6.24. So look into your NCERT books. Let us read this question together. Page 137. A bullet of mass 0.12 kilogram and horizontal speed. So we have a bullet over here, and this bullet, you know its mass and speed, and it strikes a block of wood of 0.4 kilogram and initially comes to rest with respect to the block. So it comes to rest with respect to the block. So this hit this wooden block, and comes to rest with respect to the block. So it is not moving with respect to the block, but the block itself was hanging by a string. So this block will move upwards. So this block moved upward. The block was at rest. Okay. So what is M1 here? This bullet, let us take this M1 is equals to 0.012 kilograms. And what is M2 is the mass of this wooden block. So the mass of the wooden block was M2 is equals to 0.4 kilograms. So here U1 means this just hit this block. So before hitting this block, the velocity of the bullet was 70 meters per second. Okay. And what was the velocity of the block? It was at rest. So U2 was 0. So these are the things before bullet hits. Before bullet hits the block. Or you can say before the collision. Okay. Now the block was suspended from the ceiling by means of thin wires. So there might be, it was suspended, might be 2 wires, not one, and it reached here. Okay. So this block reached height h from the base. So this is very easy question, but it's very important. Now you have to tell how much is this height. And the second thing, as I told you that there is kinetic energy loss, how much is the loss in kinetic energy that is converted into heat. So this is the second thing that you need to find out in this question. Okay. Now, as we know that in all the collisions in an isolated system where the sum of net external forces is 0, so Pi is equals to Pf. It means initial momentum is equal to final momentum. So what is the initial momentum here? So initial momentum is m1u1 plus m2u2. So m2u2 is 0, right? And that is equals to, because u2 is 0, so m2u2 is 0. And what is the final? So now both of them, see, I am talking at this point. So this point and means as it hit and just after hitting, just after the collision. Obviously both of them now moving with the same velocity, not with a different velocity, but their velocity is same. So the velocity of m1 is also v and the velocity of m2 is also v. So both of them are moving with the same velocity. So you can write it as, you can take the v common, so or both the masses are together and they are moving with the. So students, this is a type of inelastic collision. So whenever inelastic collision comes, this term, so this example should come to your mind that this bullet struck the wood and both of them are moving together. So they stick to each other. So in inelastic collision, both the masses stick to each other and move together with same velocity v. So that is what completely inelastic collision means. So complete means they completely stick together and move with the same velocity v. So if you want to find out the final velocity, so what will the final velocity? Final velocity is equals to, so this m1 m2 go this side. So m1 upon m1 plus m2 into u1. So students, put the values of m1. What is m1? 0.012. What is m1 plus m2? 0.012 plus 0.4 into what is the u1? u1 is 70 meter per second. Students, you can see one thing. Its unit is kilograms, its unit is also kilogram, its unit is kilogram, and its unit is meter per second. You can clearly see that kilogram plus kilogram will be kilogram, and kilogram cancels out. So the V that you are calculating, its unit will be in meter per second. So you can see here that the dimensional, when you study dimensional analysis, dimensions on both the sides should be the same. So this tells you the correctness of the formula. Okay, so this is very important to remember. Whenever you are writing formula, just keep in mind this thing. Okay, now this so putting the values, have you found the answer? Approximately it will comes out to be 0.84, 12,734 and 0.412, and when you will further calculate it, it will comes out to be 2.04 meter per second. Okay, so that's you have found the final velocity. This is your final velocity. So both of them are moving with this velocity. So how much is the kinetic energy lost? So let us find the kinetic energy lost. So this was the first thing you did. Pi equals to Pf, means you have used it. And the second thing we are using it, that kinetic energy loss we want to find out. So what is kinetic energy loss? So kinetic energy loss is initial kinetic energy which was greater and final kinetic energy, and that change into heat produced. This is what we need to find. So what is initial kinetic energy? So initial kinetic energy is half m1 u1 square plus half m2 u2 square, but u2 is 0. So kinetic energy of the mass at rest, means the kinetic energy of this block was 0, right? So that is equals to final kinetic energy. What is the final kinetic energy? Both of them are moving together, so with the same velocity, so I can write it as m1 plus m2 into v square. Is this clear? Now,
Yes, sir.
okay, so here it is negative sign. So initial kinetic energy minus final kinetic energy, and that loss, that kinetic energy was converted into heat energy, and you need to calculate it. So that is equals to, now put this value of V from here to here. Okay, what do you get? Half m1 u1 square minus half m1 plus m2 into v square. V square means m1 square divided by m1 plus m2, obviously square, so you will write it 2 times, into u1 also square, so u1 also 2 times. So m1 2 times, so all these things, all these 2 times. Is it okay? Now you can see that this m1 plus m2 gets cancelled out. Okay, and what is common here? Half is there on both sides. Okay, what else? m1 is here, and one of the m1 you will take from here. Okay, so one of the m1, then u1 square. So you have u1 square, you have 2 u1 here, so let us take full u1 square common. So what here you are left with? Everything you have taken common, so only 1. Minus half you have taken common, 1 m1 you have taken common, so 1 m1 is left, and u1 square is common, so u1 is not left, divided by m1 plus m2. So this is what you are calculating, the heat produced or the loss in kinetic energy. That's the same thing. So what have you got? You have got half m1 u1 square. Now this LCM will be m1 plus m2, and m1 plus m2 will comes here, so m1 cancels and you get only m2. Okay, so you have got the kinetic energy loss is equals to half m1 m2 upon m1 plus m2 into u1 square. So students, these two are very important formulas. The value of find velocity, that both the objects are moving together after they stick, and this is the kinetic energy loss in this. Okay, so you have two ways to find the kinetic energy loss. First way is, you know the value of V, so put the value of V here, you know m1 m2 and you know u1, so find the value from here. Second choice is, you put the values of m1 m2 m1 plus m2 and value of u1 here, so u1 is 70. So you have these two formulas, so you can use any formulas and you can calculate this heat, and let me tell you, this heat will comes out to be 28.54 joules. So you can use any of these two formulas. Okay, now students, look here at this formula. Let us check by dimension analysis whether this formula is correct or not. See, kilogram on the upside, multiply kilogram on the upside, and then kilogram plus kilogram is kilogram. Okay, and here you have meter per second square, so meter square upon a second square, right? And what is the formula do you have here? A dimension of this half mv square, kinetic energy is half mv square, so half into mass means kilograms, and velocity square means meter square upon a second. So here also kilogram cancels out, and you can clearly see the dimensions, the units are same on the both the sides, so it means your formula is correct. So students, always see the correctness of the formula. That is very important in physics. So how do you remember this formula with the help of this formula? So here you can clearly see that if you have kinetic energy, definitely you need, because it's mv square, so you need square of u1. Okay, so square of u1. So that's just common sense. Next thing is that because you have only 1 m here you have to cancel out, so this kilogram cancels out, but here you want 1 kilogram, and that is why you have written here m2, so that you will be left with 1 kilogram, which is m2. Okay, and you want square, so so students, just one of the way to remember the formula, multiplying it with m2 so that you have kilograms, because here you have half mv square, and multiplying it by u1, so that's square. So remember these formulas. Now the next part of the question is, so this was about the completely inelastic collision with the condition that u2 is 0. Then only these two formulas are valid, of velocity and this kinetic energy loss. So what is the condition? Condition is that m2 at rest. This is the condition. Okay, then only these formulas are applicable. Now what was the next part of the question? We have to tell the height. So students, as you know that there's only one conservative force which is acting on it, and that conservative force is a gravitational force which is actually pulling it down. So whenever there are conservative forces, we have studied in this chapter only that mechanical energy is conserved. Mechanical energy is conserved. So how can we write it? Mechanical energy is conserved. We can write it delta potential energy plus kinetic energy is equals to 0. Okay, so there is no change in mechanical energy, and you can further write it as U plus K is equals to constant at all the time. Is this fine?
Yes, sir.
Okay, so let us now do it. So what was the mechanical energy here? So here there was as the block was started moving with velocity v, but still here we are assuming the potential energy to be 0. Okay, so ui plus ki is equals to uf plus kf, right? So momentum was conserved, so this thing we have written. Now here mechanical energy is conserved, so initial mechanical energy is equals to final mechanical energy. So initial was here at this point and final is at this maximum height. Okay, mechanical energy we are talking about. When we were talking about momentum, so it was initial just before the collision and final over here. Okay, now the initial potential energy we are assuming at 0, and what is the initial kinetic energy? Half m1 plus m2 into v square, isn't it? Now what is the final potential energy? Final potential energy is mgh, so m1 plus m2 is the total mass and into g into h. And students, what is the final kinetic energy? So it was at rest here. Okay, so at rest means velocity is 0, for rest for a moment, right? It went up to the maximum height, so the potential energy was this and kinetic energy was 0 because velocity becomes 0 at maximum height. Okay, so what will be the, so this here also m1 plus m2 cancels out and you will get height equals to, so g will go, so we'll get the maximum height is equals to v square upon, so this g will go along with 2, so height is equals to v square upon 2g. Students, there is one more way to understand this concept, this question. When it was going this way, there was only one obviously the tension force is also there, but there is no work done by the tension force, because the direction of the force and the direction of motion is always 90 degree. So when the angle between the force, this tension force, and the direction of motion is 90 degree, then the work done is 0 because work done is equals to F dot S. So cos theta is 0. So there is no work done by the tension force, right? Okay. Now the concept that I am talking about is, now as there is only one force, that is the gravitational force. So this motion is in 2 dimensions, x-axis and y-axis. On the y-axis there is the force, gravitational force acting on it, but in the x direction there is no force acting on it. Okay, so if you throw a ball upwards with suppose initial velocity u and it reaches the maximum height h, so then you use the formula to find the h. V square minus u square is equals to 2 gh, right? So if you are taking upward direction as positive, so downward will be negative, so you will write here minus g into h, and as v will be 0, so you will get minus u square is equals to minus 2gh, so minus will cancel out and you will get u is equals to 2gh and h is equals to u square upon 2g, right? And in case of projectile motion, this u was u sine theta, you remember? So in case of projectile motion, it was u square sine square theta upon 2g, the maximum height of the projectile. So students, it's the same thing here also. This v was the initial velocity, and so you put these values and you get this means 2.04 square upon 2 into 9.8, and you will get 0.212 meters. So that is why this question I was talking to you, that is one of the most important questions, because it has used the concept of this perfectly inelastic collision, and along with that concept of conservative force and mechanical energy was conserved. Okay, so note it down.